There is one particular question that has come up that we would love to get your opinion on, and that is that some organizations and some individuals have proposed the idea of using a DOI to use it as a software identifier. Could you maybe comment about why, the software heritage identifier might be an alternative or a better alternative for the DOI? Yeah. Just to be great to hear your idea on that.
Question. So maybe we can let this in the recording because it may be of general interest. So I have some backup slides here. I need to find. Okay. So maybe on identifiers. When we started the software edge many years ago, my first idea was actually to put DOIs all over the graph. I was used to it. Coming from academia, you do the publication, you get DOIs on your paper. So my simple idea is, okay, let's do it. But then when you start building the infrastructure, you see actually that there are differences here. It took some time to actually understand what was going on. And I found that all this identifier thing is very confusing. It's not just today, even past. What is a name in philosophy was already a large debate many centuries ago. But I will not go into philosophy. So the only initial remark for me is, when identification and location are not the same thing. If you are used to books in libraries, identification is a book is typically a ISBN number, okay, the International Serial Book Number, and there is just one ISBN for each book out there. Even if there are 1 million copies of the book, there is just one that identifies the book, and it is actually on the book. Okay, it is standardized. Location is another story. So if I go to a library and I want to get hold of a copy of a particular book, yes, the ISBN is useful, but actually I also need to know where to look. And so here you have the call numbers, okay, for finding the book. I think a lot of confusion on the internet has come from the fact that URLs are call numbers. Okay, where can I find a particular thing on the internet? That's a call number. But since for some times URL didn't change a lot, we started thinking of URLs like identifiers. Okay, so the thing is a place where it is. And actually, if you want an anecdote, because a very good friend of mine was Jean-Marie Hulot, he was working at Next many years ago, and he told me a story by Samsung when they started building on the web their first catalog, putting in HTML everything, okay, and it costed millions of dollars to put it online at the beginning of the web, and then they discovered they had to update it the year after. Everything had to be done again. And what about the URLs? Now the URLs are pointed to a product, but now you have a new version of the product. What do I do? It was a mess. So, of course, to solve this question, DOIs were introduced at a given moment in time to allow URLs to move around. But now, here there is a second point. We are interested in identification, right? Not location. We want to identify a project, a piece of code, not to know where it is. That's of course I also want to find it, but that's another story. Okay, and so here is a distinction between two kinds of identifiers we cross in our everyday life. And there are identifiers that are extrinsic and identifiers that are intrinsic. So the main difference is what is the relation between the identifier and the object. Be patient, I will get back to the DOIs in a moment. But and here the key property we want is persistence. Okay, when I have an identifier, it is really identify that particular object. Nobody can swap it. I want to buy a box full of gold. I pay for it. I do not want to get a surprise when I open the box. It's full of lead. Okay, I do not want to have people changing things under the carpet. Well, here is an analysis of the situation. The extrinsic identifier has no relation with the object. So the only relation is not in the identifier, but in a register. Okay, typically this register is maintained by somebody. So the persistence has nothing to do with the identifier, or everything to do with the register. It is actually a function of administrative care for people who are like technology. The DOI are a special case of the handle system. and the handle system has a precise specification published 2003 in the request for comment 3650. You can click there and you will see that there is a precise statement that persistence is a function of administrative care and that the system by itself does not guarantee any form of persistence whatsoever. Okay, one needs just the point is that then we say persistent identifiers. You get the kind of cognitive dissonance there. Okay, so the only way is to actually go there and understand. There are a lot of extrinsic identifiers. Your passport number, a book number, the social security number. If you only have my passport number, this doesn't identify me at all. The only way to know that this is me, you go to a register which is maintained by the state. They say, this number is a passport of Roberto Di Cosmo. But if you lose the register, you are dead. Okay. And in the internet era, you have a lot of extrinsic identifier schema. For example, the DOI, the handle, the ARC, etc. They're built in the very same way. So you use a register to keep a connection between what is called an opaque identifier. I mean, typically on DOI they say this, but this is the dangerous thing, not the object, and the location where you think you can find a copy of the object. I do not know if somebody ever tried to follow what happens when you click on a DOI link. So behind the scenes, the server connects to the register. I mean, that is called the resolver. The resolver look up in the table what is the correspondence between this DOI thing and the URL and returns you a URL. And your navigator, your browser, goes to the new URL. Okay, so it is an association between an identifier and the location, not an object. Okay, so you have no guarantee that the association is correct or maintained over time. It all depends on who does that work. If you look at intrinsic identifier, also our life is also full of intrinsic identifiers. I mean, the idea is that the relation between the object and the identifier is not in a register. It's based on a convention that we all share. And the persistent has nothing to do with somebody maintaining a register. There is no register. It is by design. So typically, the music notation, the chemistry notation are example of this. So when you write down NaCl, sodium chlorine, which is stable salt, you do not need to look up in a register what it is. And nobody ever thought of putting a DOI on all possible notes on the musical scale. Okay, of course you don't do that. Well, we have two systems, the European with do, re, mi, fa, sol, la, si, do, and then you have the American with A, B, C, but okay. But once you agree on the standard, it's very easy to find the object. And if you look at the digital world, also you have cryptographic hashes, which are intrinsic because they are built out of the object itself, but you need to agree on the convention, what cryptographic algorithm we are using. If we all agree on the cryptographic algorithm we are using, or if you all agree on the standard document, this is why we wrote the standard document for the sort of hash identifier, everybody can rebuild it. We agree on the document, there is no need of a register whatsoever. And this is very popular. Git is built like this. Bitcoins work like this. And the sort of hash identifier was the same way. So sorted development is massively done using these intrinsic identifiers. So our identifier is a kind of a glorified version of the same identifier that every millions of software developers use every day for doing software development. Git, GitHub, GitLab, pull request, issues, geeks, nicks, all this work using the same intrinsic identifiers. And if you really want to have replicability and reproducibility trusted, that is to say, I really get the right version of the software, it is much better to have an intrinsic identifier than an extrinsic one. You can live with an extrinsic identifier, but you have less assurance that what you get is what you want. And so the other point is that since the beginning, we decided to choose as a cryptographic algorithm the same cryptographic algorithm that is used by Git. So this, the software hash identifier is naturally, immediately, directly compatible with everything which is developed by Git, which is a large majority of what is in the world. So this is explanation why we are using this identifier instead of putting 50 billion DOIs There is also a reason that I cannot pay 50 billion DOIs to put on the graph. I mean, to be clear, I mean, so even with discount, I'm not sure this can be paid. But it defeats the purpose of maintaining the history. But this doesn't mean that there is a conflict between DOI and sorted hash IDs. They are complementary. So, and this is a picture from Morane. I mean, so Morane did a wonderful work on this document with the Research Data Alliance a few years ago. Sorry, Morane, do you want to explain it, or I go?
It's actually very hard to explain it. It's one of the hardest diagrams to explain. It's we usually lose the audience when we explain this diagram. Okay. I agree that it is a very good diagram showing the differentiation of the granularity levels. But I think that we can move to other topics since.
Then let me take 2 seconds to go through.
Go ahead.
The diagram is great. So when you had a project, typically you use intrinsic identifier when there is a canonical form for the digital object. What is a canonical form? It is a representation of the object that is really unique. It is not the case for publications. You do not have a canonical form of a digital publication. You can have a PDF, a PostScript, a PDF-A, a PDF compressed, whatever. It is the same paper, but physically it's not the same sequence of bits. For software, it is very, very important. It is a very equal system of bits, because you change a bit, it doesn't do the same thing, okay? And so if you have a canonical representation, you can use intrinsic identifier. If you don't have a canonical representation, you need to resort back to the register. And typically, if you have a project, and the name of the project is, I do not know, Emacs, Python, R, what is a digital representation? You don't have it. You cannot compute a hash. So there, you put all these extrinsic identifiers. It can be a DOI, it can be a Wikidata property, it can be a research resource identifier, it can be a sorted hash, sorted math identifier, a HAL ID, whatever. Then you have a register that say, you use this thing, this actually points to that metadata that describes the Python language. Okay. And this works very well for a project or these kind of things. But as soon as you go down to things that have a canonical digital representation, I mean, a file, a code fragment, a directory, commit, revision, release, a snapshot, then you really want to use intrinsic identifier, because this guarantees that this is exactly the object you wanted to have. Okay, so basically this means a real complete description of a piece of software usually comes with 2 things. One, which is the intrinsic identifier of the software. And the second, that actually gets you a pointer to a place where there is a description of the project. And actually, we already do it. If you look at the software hash identifier completely, the core identifier is intrinsic. But the other extra information saying origin is GitHub / something, etc., this is extrinsic. You need to go to GitHub and see what it is. So we actually provide a way of getting both things. And so in citation for software, typically, you should have both. So typically, if it is just citing a piece of software with no version, nothing specific, just put the DOI with a pointer to the description of the project. As soon as you have source code or variant or revision you want to actually reproduce, then you need to have the intrinsic identifier, because this is a way software development works. It's a long answer, but I wonder if this helps clarify a little bit the situation.
Thank you so much, Roberto. I don't think we expected such a deep answer, but I'm so glad we got that on the recording, because if anyone ever asks it again, we'll absolutely need to refer to this. That was superb, and thank you so much. And there's been great comments as well in the chat.